All right, welcome back to our webinar for Certified Fire Protection Specialist exam preparation. And our topic for tonight is about basics of fire and fire science. So let us start so we can finish early. Okay, so welcome to our Certified Fire Protection Specialist. Our topic is basics of fire and fire science. We will learn in this module the basics of fire science and demonstrate familiarity with how the fire grow in an enclosed space and the ways as well to contain. We'll also learn about the methods of the fire detection and ways fire can be extinguished. We'll obtain an introduction to fire suppression system and portable fire extinguisher as well. If we will complete the module, we'll be able to recall the topics related to Section 2 of the Fire Protection Handbook, define the chemistry and physics of fire, which try to explain the structure of premix and diffusion flame, describe implication of burning fuel-rich, oxygen-rich, and stoichiometric fuel-air ratio, and use the physics of fire configuration to determine the flame shape and motion, the heat transfer, and flame spread rates. Also, to identify the feature of fire growth, describe the 4 ways to classify the fire, and explain how compartment boundaries change the fire growth. And again, this is related to Section 2 and 17 of your NEP official manual, Fire Protection Handbook. We will not cover those we are not expecting to come out in your exam. Okay. Okay, according to U.S. Fire Department, there are estimated average of 355,000 home structure fire per year from 2012 to 2016 that caused an average of 2,560 civilian fire deaths. And those average are roughly half as high in 1980. While the decrease in this number may sound encouraging, certain scenarios have appeared to be more dangerous compared to the past. For example, the death rate per 1,000 home fire was more than twice as high in the fire that began with either upholstered furniture or mattresses and bedding. To understand the variability of how the fire began and spread to result in civilian death, injury, and property damage as well, it is important for us to understand how the different types of the contents of the building materials and the room configuration can impact the fire ignition and the growth. We will also find more further information by going to your, I already shared you some materials, okay? The name of that material is the Home Structure Fire Research. So if you have time, you could be able to spend a time reading that, no problem. Let us discuss the fire behavior, and in order to understand, it is necessary to have at least the basic knowledge of the following. Okay, chemistry, the physics, heat and mass transfer, fluid dynamics, especially the physics of, and chemistry of fire and the dynamics of fire growth. And we know that the fire is a very complex phenomenon. And to gain an understanding of fire behavior, it is necessary for us to have at least the basic knowledge of those. And the module, which we will discuss tonight, are arranged in these two things. No? Again, the physics of and chemistry of fire and dynamics of fire growth. So let us discuss first the physics and the chemistry of fire. The fire triangle illustrates the three components of the fire needs: fuel, which is something combustible; an oxygen, which is, we call it also an oxidizing agent; and the heat. The fire event occur when all of those three components are present in the correct amount. That is the reason why the traditional fire extinguishing method involved removing one of the three necessary components, either the fuel, the heat, or oxygen. And in absence of one of the components of this fire triangle, theoretically, there is no fire. There should be no fire. Let us define the ignition. It's a process by which self-sustaining combustion is initiated. An ignition source in the form of a spark or the small flame provides the minimum amount of the energy needed in order to start a chemical reaction between the fuel and the oxidizer. The combustion reaction produces more energy than it consumes, providing the energy needed to propagate the reaction throughout the mixture. Remember guys, the ignition, as what we discussed earlier, is a process of self-sustaining combustion. Okay? And the flame is self-sustaining as long as a fuel and the oxidizer are available in the right amount or concentration. As a fire science advanced, the fire triangle evolved from three basic components or elements of fire to fire tetrahedron, okay, which now include another fourth component, the uninhibited chain reaction. So what is that? So a chemical reaction is a process by which reactants are converted into products. More often than not, the equation is used to describe a chemical reaction hides the details of the mechanism by which the change takes place. Stoichiometry, as what you can see on your screen, it is described the instance when the exact amount of fuel and oxygen exists in a fire so that in the end, no reactants remain. And this is rarely no, happen, except perhaps where there is a mixture of fuel and oxygen is controlled, such a burner on a gas stove. The stoichiometric flame produces the most efficient reaction and the hottest temperature. So if you can see this guys, it is just a chemical balance equation. No? CH4, the two oxygen, 2O2, will produce a carbon dioxide and two H2O. No? So it's just a chemical balance equation, which we call it stoichiometric equation. And this equation produces the most efficient reaction and hottest temperature of fire. It is very important for us to understand that the flame process arise from the detailed experimental studies of premix flames. Let's discuss the chemical reaction and the oxidation reaction. And we can express the oxidation reaction as the balanced chemical reaction, showing reactants and the products in their stoichiometric proportion. However, it is simply a statement of the proportion of stable final product that result from this combustion process. It hides a complexity of detail. The conversion takes place by a series of elementary reaction. Elementary meaning they cannot be split into simpler chemical steps. And this involve the reaction of free radical, which are highly reactive molecular fragments produced during the reaction sequence. And we have a table in your fire protection handbook, which you can found in your chapter 2, table 2.1.5, the reaction mechanism for the oxidation of methane. So what are those? Those are the principal elementary reaction that you can found again in your fire protection handbook, table 2.1.5. Okay. Okay, let's check our knowledge using the fire protection handbook. So extinguish the fire by answering each of the following question correctly on the first attempt. Okay, so you can use our chat box to provide the right answer. Metal cutting, which is a type of hot work, can produce literally thousands of sparks. What can these sparks serve as? Fuel source, oxidizing agent, or ignition source? Actually, not only in metal cutting, no, I've seen also in the welding works, no, there are also many sparks, no. So, Mr. Norman, you are correct. Those sparks can serve as ignition source. Okay, and introduction of ignition source in the form of spark or the small flame will result in the propagation of the flame through a flammable vapor or air mixture. Okay. Question number 2. In addition to oxygen and heat, what is the third components of the fire triangle? So, Mr. Rahil, your answer is A, your fuel. That is correct. The fire triangle illustrate three components of the fire: fuel, something combustible; oxygen, which is an oxidizing agent; and heat is in a form or radiation. Another question. In the fire tetrahedron, includes oxygen, heat, and fuel. What is the fourth component? Okay. So the fourth component is the B, uninhibited chain reaction. The fire triangle evolved into fire tetrahedron, now include fourth component, the uninhibited chain reaction. Okay. A flame is a self-sustaining as long as a fuel and other component are available in the right concentration, pyrolysis, oxidizer, or ignition source. Okay, so the answer is, okay, so Mr. Rahil, you are again correct. So a fire is self-sustaining chemical reaction that continues as long as these components are present in the right amount. This is why traditional fire extinguishing method involve removing one of the three needed components, either heat, fuel, or oxygen. Another question. Which of this method would create stoichiometric combustion, increasing the heat to the level of oxidizing agent, decreasing the flammable vapor, or balancing the level of fuel and the oxygen? So Mr. Conrad, you are correct. We need to balance. We need to have a right amount, no? Fuel and oxygen to create a stoichiometric combustion. Stoichiometry describes the instant when the exact amount of fuel and oxygen exists in a fire so that in the end, all that is left is a carbon dioxide and a water CO2 plus 2H2O based on the equation. That is the product. That is what we call also a product of combustion. Pyrolysis and gasification are processes by which the solid and liquid fuel are converted to flammable vapor. As you can see on the screen, pyrolysis is a chemical decomposition of a compound into one or more other substance. All the solid combustible must undergo pyrolysis in order to generate fuel vapor for flaming combustion. So what happened here, the pyrolysis, a solid material, for example, a solid combustible material will be heated in the form of pyrolysis, which will generate vapor to support the flaming combustion. Another term is heat of gasification is the amount of energy required to produce the flammable vapor from a combustible solid which was initially at an ambient temperature through pyrolysis. Okay? So this is also a process of converting solid to vapor. So that is heat of gasification. So if there's a heat, the solid converted into vapor and may also take many physical paths depends on the chemical composition of the fuel. For example, the wood decomposes directly to gaseous vapor when heated. On the other hand, if the plastic is heated, will undergo in a two-step process in which it will first melt because that is a characteristic of plastic and become a liquid that then is vaporized into a gaseous fuel. Okay? Again, that is a term, heat of gasification, amount of energy to produce flammable vapor from the combustible liquid through pyrolysis. Okay? Now let us discuss the flame structure. There are two types of flame, a diffusion flame and a premix flame. Diffusion flame occur when the oxygen mixed with fuel at the point of reaction, which is the flame surface. Typically produced, if you see on the screen, about like yellow or orange flame. On the other hand, the premix flame occur when the fuel and oxygen come together before the point of reaction. So that is the big difference. No? Diffusion of flame with this diffusion of flame, mix of fuel and oxygen at a point of reaction. But premix flame, before the point, no? I mean the fuel and oxygen mix before the point of reaction. And this reaction occur throughout the visible flame, typically produce a blue flame. This is type of flame normally produced by Bunsen burner and even our kitchen gas stove. No? So basically, it is a premix flame where the fuel and air come together first before certain point of reaction. Okay. Fire in an open environment demonstrate the behavior of diffusion flame and illustrate how fire draw the oxygen. See if you can identify the contagious flame, intermittent top of the flame, and the buoyant gas in this video on the next slide. Match its item to where it belongs to fire. Okay. Anyway, before that, let us uh, read the definition of the following. Continuous flame, what is continuous flame? Intermittent flame, and fire plume. Continuous flame, when the fuel material is heated by ignition, fuel and air come together to form a flame. As the flame develops, the fire pulls oxygen from the surrounding atmosphere, which is known as entrainment. So the term entrainment is a pulling of oxygen from the surrounding atmosphere. So that is the support that the fire will be work continuously. So if you see here, guys, I don't know why the video is not working. So if you see, um, the fuel material is heated, okay, and air in the form of entrainment support the continuous flame. Now on the top is intermittent flame, and as entrainment occur, okay, or the fire pulls oxygen from the surrounding atmosphere, the area at the top of continuous flame will flicker or appear intermittent. Fuel comes up at the surface of what is burning. And the fire plume is hot gas become buoyant and move upward. We know that in the physics that the hotter air, even a hotter object, or how can I say, the better term is the denser, the cold air is denser compared to hot material or gas. Okay, so that's the tendency of buoyant. No, hot gases tends to move upward. So this hot turbulent gas rise in a fire plume. The action of the hot gases rising due to buoyancy. So that's what is fire plume. It is an action of a hot gas due to buoyancy, cause the cooler air to become entrained in the flume. Okay. Okay, let us check what we have learned. Procedure for risk reduction in a laboratory should address the handling and storage of chemical and the flammable and combustible liquid, and the use of open flame such as Bunsen burner, which produce premix flame, as what we discussed earlier. The type of flame is typically blue. What type of flame produced by a Bunsen burner? So answer. Okay, so we discussed earlier, it's a premix flame where the fuel and oxygen come together before. So that's the term before. It gets the point of the action. So let us see. Another question. The air is required for combustion of the fuel vapor is drawn into the flame from the surrounding atmosphere by a process known as blank. Pyrolysis, entrainment, ignition. So what is the answer, guys? Okay, Mr. Conrad. That is entrainment. Fuel material is heated by ignition. Fuel and air come together to form a flame. As the flame develops, the fire pulls in the oxygen from surrounding atmosphere, which is known as entrainment. So, okay, very good. Okay, let us see. Another question. For the process of combustion to be self-sustaining, it is necessary for the burning gas to impart sufficient heat energy to the material to continue the production of ignitable volatile. The energy required to convert, okay, the question, the energy required to convert solid material into flammable vapor is, okay, Mr. Rahil, you're correct. That is heat of gasification. It's an amount of energy required to produce flammable vapor from the combustible solid, which was initially at ambient temperature. Another question. Liquid hydrocarbon normally burn with orange flame and emit dense clouds of black smoke. A pool fire involves liquid hydrocarbon and oxygen mixing with the fuel at the point of reaction. This is the question. What is the type of flame produced with a hydrocarbon pool fire? Question, answer? Okay, I think you provided the answer, Mr. Rahil. That is correct. Diffusion flame is an oxygen mixed with fuel at a point of which the flame surface. Okay. Now we'll go back to our module layout. Now let us discuss the dynamics of fire growth. No? We finished the physics and chemistry of fire. So now we will go to dynamics of fire and the fire growth. At this point, ignition has taken place and the fire reached the point of established burning. As a heat continually added, the fire expands, the plume rises to the ceiling because of buoyancy, and all combustible elements are brought to their ignition temperature. The physics of fire transition into dynamics of fire growth. Let us discuss, okay? And in this section, dynamics and growth, we will focus on applying the basics of fire dynamics and the fire growth. The early stage of fire provide the driving force for growth and spread. The rate and amount of energy produced by the initial fire will frequently determine whether the fire will spread beyond that area or compartment. The fire serves not only the source of energy, providing the flame and heated gases. Sorry guys, I have to turn off the, okay. Okay. The rate and the amount of energy produced by the initial fire will frequently determine whether the fire will spread beyond that area or compartment. The fire serves not only a source of energy, providing flame and heated gases, but also as the source of smoke particulates and corrosive gas, which are what we call the products of combustion. No? So let us discuss the flame spread, smoke develop, heat release rate, and fuel loading. So what is the flame spread? Just as the term implies, the flame spread reference the act of how the flame move across the fuel or on the surface of what is burning. It is the mechanism of how the heat generated from the initial flame and transferred and ignites neighboring material. So basically, if you remember in your during your college days that there is a three form of heat transfer, no? Conduction, convection, and radiation. So in the other means, this is also applies here, no? This is how the flame spread, no? However, when thinking about the flame spread in the built environment, the fire protection professional needs to concern themselves when mitigating or minimizing the flame spread, as well as how the fire can be extinguished before it spreads further. Imagine that a builder is going to build 20 homes. The following things we need to consider are what kind of roofing or other specific construction materials should be allowed. Another question is where should the hydrants be located, which is a form of fire suppression equipment, and how far apart should they be? And another important question is how are the access roads created to get the fire truck in and out of the neighborhood in case of emergency or fire? Let us discuss the smoke development. Recall that the fire is self-sustaining chemical reaction causes the fuel to vaporize and create small chemicals that are carried by the fire plume. Smoke is made of remaining solid, remaining liquid and gas particle that do not combust. So that's where the smoke is generated. It's like a byproduct of the fire. Smoke are the toxic and the toxic gas contained in it are the primary cause of fatality in fire. That's according to the research. It is the smoke, including toxic gases, are cause of most of the fatality or death compared to fire itself. Not because of inhalation, but also due to impaired visibility, which can prevent escape from threatened area. Another term is heat release rate. No? So heat release rate refer to more than just the temperature coming out of the fire. It is the property of a particular fuel. How much energy does the fuel give off? So that is heat release rate. How much energy does the fuel gives off? The heat release rate or HRR measure the rate at which burning item release chemical energy per unit of time. Okay, so let us see. So if you see guys, it's about 20 seconds. This dry fir tree burn at a heat release rate in kilowatt of about, you see, it's almost 4,000 kilowatt. And as the fuel, okay, reacts, no? So at a certain time, the heat release rate will drop. So the heat release rate is considered most important quantity used to characterize the flammability hazard represented by a given material. So guys, this kind of chart is typical, almost typical to any material, but the time because of the flame spread and uh, smoke develop depends what kind of material you are subject to burning. So it's not, the time might not be typical. Fuel loading, okay? The concept of the fuel loading is a way To characterize potential hazard of the fire severity in terms of the amount of available fuel in the space. So meaning total fuel material over the total space. It is also important to consider whether those items are close enough together to propagate or spread the fire. The fuel load is determined by adding up a fuel present and dividing it by the planned area or total space or of the compartment or of the fire space. And the result is the length of time the building will be expected to burn based on the total amount of fuel available and the total energy produced. So again, the fuel load is determined by adding up all fuel present and dividing it by the planned area of the compartment or the fire space. It is frequently useful to classify the fire in order to simplify communication pertaining to certain common characteristics. So let us discuss those fire by characteristics. No? And the fire have been characterized in the four general ways: type of combustion process, the growth rate, the ventilation, and the fire stage. Let us discuss the type of combustion process. Perhaps the simplest description of a fire classification is to divide the fire type by the type of combustion process. Either the pre-combustion, smoldering, or in Tagalog, it's like baga, no? But there's no sufficient heat to produce a flame. If you remember that, the smoldering, no? And the flaming combustion. Okay. Pre-combustion is the process of heating fuel to the ignition point, during which vapor and particles are released from the fuel. Let us now define the smoldering. Is a glowing combustion on the fuel surface and where the fuel vapor and temperature may not be sufficient to support the flaming combustion. And lastly, the flaming combustion is almost self-explanatory. There is a sufficient energy and fuel mixture, vapor mixture to support the presence of the flame. And the growth rate, fire may also be classified on the basis of growth rate. And the fire growth can be either positive or negative, meaning its growth is increasing, or negative, meaning it is a decreasing growth rate. As what you can see on the diagram. A second category used on a growth rate is steady state fire. Under the steady state fire, the fire heat's output or heat release rate remains relatively constant. So relatively meaning almost constant over time. So that is what we call a second, that is a second category of fire. We call it steady state fire. A third category is a burnout or a decay condition. Occur when there is a plenty of air, but HRR decrease because the fuel is burned or consumed. The last way to categorize the fire by growth rate is the speed at which the growth accelerates. Such fire are considered time dependent. Fire are described by an exponential growth rate. Growth can be slow. The growth can be medium fast or ultra fast. And another actually uh, Another also diagram is also presented to show those type of growth rate. Let us discuss the ventilation. Fire may also be classified based on whether the fire is controlled by the amount of fuel available to burn or by the amount of oxygen or air available for the combustion process to continue. When a fire is burning in the open or is in the early stage of development within the compartment, when there is an excess air for combustion, the fire is said to be fuel controlled. Okay? Again, fuel control by ventilation is where there is an excess air for combustion, excess air of combustion, or when fire is in the open. Okay? Ventilation control, once the fire develops to a point where it is produced more fuel vapor than can be consumed in the compartment within the available air, it is considered to be ventilation controlled fire. Again, ventilation control is the fire produce more fuel vapor that can be consumed in a compartment. So it's not open. It is closed or in a compartment, and it is ventilation control. Fire stage, there are 4 stages of fire. We will discuss: incipient, growth, steady state, and decay. I also call it the fire life cycle. No? Incipient stage refers to the first stage of the fire where the heat, oxygen, and fuel source combine and have a chemical reaction resulting in a fire. So this chemical reaction produces the fire. In this stage, there is smoldering but insufficient flame to establish the burning. So smoldering will take place but insufficient flame to establish burning. Another is the growth phase, represent increasing fire growth with respect to the heat release rate over time. And during this stage or phase, the fire load and oxygen are used as a fuel for the fire. This is a short stage, but flashover can occur, and as what we discussed earlier, flashover is like it makes a compartment untenable, unattainable, or no life can survive. That's what flashover can do. Next, after the growth phase, the steady stage, when the heat release rate or HRR is basically constant and there is a considered to be fully developed. This is the hottest stage of the fire. So in this stage, the heat release rate is basically constant, yet hottest stage of the four fire fire stages. Okay. And lastly, in decay stage, the heat release rate decrease over time because of a significant decrease in oxygen or fuel, which would put an end to the fire. Even you don't suppress. Maybe the fuel is running, so probably running out of fuel is the reason. Therefore, there is a that's the end of the fire. Unless there is a reintroduction of combustible material through radiation, for example, or oxygen. Okay, let us again check the knowledge. A charcoal grill is lit and the result is glowing combustion on the surface of the charcoal. What is this an example of? Answer? Answer, guys. Okay, let us see. Maybe Rahil answered it correctly. The answer is C, smoldering. Okay, is defined as going combustion on the fuel surface and where the fuel vapor and temperature may not be sufficient to support the flaming combustion. Okay, another question. A pool of gasoline is ignited. The heat release rate grows rapidly as the entire surface of the gasoline becomes involved in the flame. Now, the HRR of the fire is staying constant over time as the pool continues to burn. What type of growth rate is the pool fire currently in? Okay, so Mr. Brian, that's right. The steady stage is when the heat release rate is constant and the fire is considered to be fully developed. This is the hot stage of the fire. Another question. A fire begins in a bed within the bedroom with the door closed. What will the fire likely become as it continue to burn? Answer. So it is in the close or in the compartment. No? The fire is in the close or in the compartment because the door is closed. So what kind of uh, fire? So Mr. Conrad, correct? Mr. Brian, that's right. Once the fire develop to a point where it produces more fuel vapor that it can be consumed in the compartment with an available air, it is considered to be the ventilation controlled fire. Another question. The HRR of the fire in the living room of a single family home begin to decrease as the available fuel in the room is used up. In what stage is the fire? Okay, thank you, Mr. Brian. That's right. In the decay stage, the heat release rate is decreasing over time due to a significant decrease in oxygen or fuel putting an end to the fire unless there is a reintroduction of combustible or oxygen. Next question. In order to start a campfire, the wood must first be heated up to its ignition point. At this time, the wood will begin to release vapor and particulates. What step in this in the combustion process? Remember, guys, the keyword is the wood must first be heated to its ignition point. So that is what we call Mr. Conrad, Norman, Rahil, Norman. Okay, correct. That's right. Pre-combustion is the process of heating fuel to their ignition point during which vapor and particulates are released from fuel. Okay, that's correct. So I think this subject is too easy for us, for you guys. After the pre-combustion, the wood in the campfire ignites and the size of the fire increases. What stage of the fire growth it is? Okay, so I think Mr. Brian, it's too easy for you. The growth stage describes the time when the growth rate is positive and the heat release rate or HRR is increasing to its maximum value. Okay, another question. The campfire is burning outside in the wood. What type of fire it is? Okay, very good, Mr. Conrad. That is fuel control. And just to remind you, when a fire is burning in open, or is it the early stage of development within a compartment when there is an excess air for combustion, like, you know, like the woods, campfire, no? Outside in the woods, the fire is said to be fueled controlled. Okay, thank you, Mr. Brian. Mr. Kaliswaran, very good. Mr. Rahil, and all of you, Mr. Rahil, Conrad, definitely you will pass the exam, no? There was WhatsApp video, huh, guys? Effects of compartment boundary.
Tree of fire. You learned that fire plume and buoyant gases rise up in the open environment. Now let's imagine you are inside a building. Rising hot gases proceed to the ceiling, which then turn horizontal. This is called a ceiling jet. As it goes across the ceiling, it starts to form a hot
I don't hear the sound, no? Let me increase the volume first.
tree of fire. You learned that fire plume and buoyant gases rise up in the open environment. Now let's imagine you are inside a building. Rising hot gases proceed to the ceiling, which then turn horizontal. This is called a ceiling jet. As it goes across the ceiling, it starts to form a hot layer. The hot layer gains depth as more and more of the fire gases rise to the ceiling. As the layer becomes deeper, the more the heat starts radiating down to the floor.
And that this heat of radiation may also cause a fire. Because the heat transfer, that necessarily there is a physical contact, no? And that's one example of heat of radiation. Physical contact is not enough. The energy released, no, in the atmosphere might be enough to continue or propagate the fire. Okay.
Tree of fire. Tree of fire.
In the physics and chemistry of fire, you will learn that the fire plume and buoyant gas rise up in the open environment. Now, let us imagine you are inside a building. So again, this is just to recap. Rising hot gas produced to the ceiling, which then turn horizontal. And this is called ceiling jet, now turning the vertical to horizontal direction. As it goes across the ceiling, it starts to form hot layers according to the video as what we have watched. And the hot layer gain depth as more and more of the fire gases rise to the ceiling, and it's because of the fire plume or buoyancy. And lastly, the layer becomes deeper the more the heat starts radiating down to the floor. Okay. When the temperature at the plume center line, okay, reach the temperature of the surrounding air, the gas and smoke stop rising. Again, if the flume center line reach the temperature of the surrounding air, the gas and the smoke stop rising. This is known as stratification. If you see there is a equation on the right side, plume center line temperature is equal to air, the surrounding air. So no more uh, uh, gas and smoke rising. Why? Because typically the temperature in the surrounding are same. There's no hot or cold. Everything, there's no cold air here anymore. All are hot. This phenomenon is frequently observed, particularly On a calm day, when the smoke from a chimney or the industrial stock rises to a certain level and suddenly stop and begins to spread out horizontally. Why? It does this because that there is no longer buoyant force causing the gas to rise vertically. So the buoyancy, meaning the hot air is less denser condensed compared to colder air, and no more colder air. So instead, it will goes up in the chimney. It will start to spread the smoke horizontally. Okay. The same condition can develop in a tall space within the building, such as in an atrium, resulting in the stratification of the smoke and the hot gas. And such phenomenon may result in a delayed operation of sprinkler or detector. This is a problem. In some case, failure to operate at all because again, there is no more rising of hot gases. Uh, that's why if you have an atrium, it's also important for you to have a sprinkler below. No? As the fire continues to grow, the heat radiates from the fire. The hot gas is spread out across the ceiling and then start radiating down to the floor. As the temperature keeps rising, it gets to the point where it starts giving off fuel gases. So if you see here, guys, here at let's say the upper area is about 600 degrees C, and it produces 20 kilowatt per square meter. Probably this material enough to burn in an energy amount of 20 kilowatts per square meter. Okay, so without physical contact within the fire or within the smoke, okay, or within your ceiling jet, it will also burn. And this is where the term flashover will occur. There is a pivotal point when the room reaches a certain temperature where everything in the room catches fire. This is known as flashover. The key is to get the people out before it's happened because it makes the place unattainable or no one can survive. No one can survive the flashover. Flashover is not an inevitable result of a compartment of fire. If the fuel is limited or if there is a sufficient large ventilation opening, the ceiling layer may not develop adequately and the transition to full room involvement. Flashover can also be prevented by early application of suppression system like a sprinkler, either automatically or manually. Maybe let's say from your fire hose cabinet, no? You're using the fire hose wheel to suppress the fire. So let's watch a video about the flashover.
1 minute 4 seconds from first flame. Smoke begins to fill the room. 1 minute 35 seconds. The smoke layer in the living room descends rapidly. Gases flowing out of this room now exceed 190 degrees Fahrenheit. 1 minute 50 seconds. The smoke detector at the foot of the stairs sounds an alarm, providing warning before exits are blocked. Take action immediately. Crawl low where the air is cleaner. 2 minutes 30 seconds. The temperature above the couch is now 400 degrees Fahrenheit. 2 minutes 48 seconds. Smoke pours into the dining room. Thick black smoke moves rapidly upstairs. 3 minutes 3 seconds. Melted polyurethane burns under the couch. Suddenly the lampshade ignites. The temperature 3 feet above the floor in this room is over 500 degrees Fahrenheit. No one could survive. From the outside, there may be no evidence of the inferno inside. 3 minutes 41 seconds. The energy in the room suddenly ignites everything. Within 1 minute, the temperature has risen to over 1,400 degrees. Flashover.
So again, in flashover, no one survived.
1 minute 4.
So that's the idea. No? You have to escape in your means of egress before the flashover occur. Okay, check your knowledge number 12. A mattress has been ignited within the bedroom. As the fire grows, the fire plume and buoyant gas rise to the ceiling. Okay? Once these gases and smoke hit the ceiling, they begin to spread out across the ceiling and eventually reach the installed smoke detector that will sound to alert the occupants. What are the hot gases called when they spread out across the ceiling? Answer? Okay, all of you guys correct? No? So Norman, Mr. Normal, B. So that's right. The rising hot gas go to the ceiling, and once they get to the ceiling, they turn and starting to get going horizontal because of what we call ceiling jet. Okay, another question. The smoke and plume from the mattress were able to reach the ceiling because the increased temperature of the plume created buoyancy. If the room was tall enough, the plume may cool and stop rising before it reached the ceiling. What is this phenomenon called? Okay, so Mr. Brian, you're correct. I think Mr. Brian is ready now to take your CFPS exam. When the temperature and the plume center line reach the temperature of the surrounding air, the gas and smoke stop rising. This is known as stratification. So Mr. Norman, you're also correct. Another question. What effect can the stratification of the fire plume have on the sprinkler activation if the sprinkler are located at the ceiling? Okay, so that's correct, Mr. Rahil. No? It will cause delay or failure of operation. Stratification of the smoke and hot gas may result in delayed operation of the sprinkler or detectors, in some case failure to operate at all, because stratification means there is no buoyancy anymore. That might cause your detector failure to operate or delay. Okay, so that will be the two potential reaction. That's why, guys, I remembered when I was in a warehouse building, which the ceiling is about, I think, 16 meter or 18 meter high. We have this what we call a smoke beam detector. Okay, at a lower level, because of this effect of ceiling jet, we do not want this to happen, and especially the stratification, because at some point it will travel horizontally. So that's why I think every 4 meters, no, we install beam detector. That's what I remember, but please check your NFPA 72 standard for the location, height, and location of your smoke detectors. No? At what temperature does the fire plume stop rising? Answer? Well, we discussed if the center line of the fire plume has an equal temperature to the surrounding temperature. So B is correct, no? So at a temperature, does the fire plume stop? When the temperature of the plume center line raises the temperature of the surrounding air, the gas and smoke stop rising. Okay, another knowledge check. As the mattress continue to burn in the room, the hot gases collect at the ceiling and begin to radiate to all of other fuels within the room, which causes all of the fuel to start giving off gases. What is the name of the event? in which everything in the room catches the fire and no one survived. Everyone agree? Conrad, Patrick, Norman, okay? And all of you guys, okay? The flashover core, when all of the combustible materials in the room ignite and the room makes no more unattainable or livable, no? Everyone might die. So before that, you should escape out of the compartment or building. Fire can be classified by the hazard class and define the fuel type, which you are very familiar. Normally, you can see it in your portable fire extinguisher, your portable fire extinguisher. There is a classification by fuel. So based on the type of fire, you will use the appropriate uh, fire extinguisher classification. But anyhow, forget about the fire extinguisher. Okay. The important here is the class according to NFPA standard. Class A is a fire with ordinary combustible material. Class B, fire with flammable liquid. Class C, fire involves electrical equipment that might involve Class A or Class B fire. But in this case, there is an added electricity that might cause electrocution. The Class D, fire in combustible metal. NK is also like the B, flammable liquid, but normally from the kitchen or a fire in a cooking appliances. Let's say uh, oil from animal and oil from the plants. No? And now we have completed the module. Let us recap. This module discuss the section 2 of your fire protection handbook and review the chemistry and physics and dynamics of fire. And you also learn about the chemical composition of ignition and the roles of pyrolysis. We discussed and the heat of gasification in a self-sustaining fire. We also examine the structure and the premix and diffusion flame, as well as the implication of fuel and the oxygen-rich burning in an open environment. We also include a review of how the heat release rate, the fuel load, the flame spread, and the smoke develop play a role in the growth of fire, which was followed by the demonstration of how this growth changes with the boundaries and the compartments. And lastly, but not the least, you learn how to classify the fire by both of its characteristics, as well as by the hazard it present, the type of fuel used to ignite it. Okay? So I think there's no questions because I think everyone is getting the right answer. So now we'll go to the significant Part, I mean, let us allow me to share with you your quiz web link for tonight. And again, you need to get 70% in order to pass. No? Okay? So this is the question I'll post now in our group, in our chat box. So you can start answering it now. And after that, we will also discuss the answer later. So please start answering it now. So there are 12 questions. So I'll give you probably 15 seconds to get the right answer. time is up. Let us determine the right answer. Let me check your responses. No? Today is June 2. So most of you guys, and there is one guy who perfect the exam. So Mr. Rahil, congratulations. I think you are prepared to take your exam. Okay. Anyway, let us discuss the right answer. Those who didn't get it 100% correct. Okay. Okay. I hope, Mr. Rahil, I think you already booked your CFPS exam. I hope you will pass. No? So hope for the best. Anyway, when a compartment fire transition from a fire dominated by the first material ignited to fire that is dominated by the burning material throughout of the room, we call it passover, page 100 of your handout material. The fire stage by heat release rate be controlled by the fuel package size and geometry or by the available ventilations to support combustions. We call it steady state. Okay, this is the phase, this is the hottest phase. No? The term blank describes the average amount of energy required to produce a unit of mass of flammable vapor from a combustible solid, heat of gasification, page 33. You call to investigate a fire that occurred in a food court of a shopping mall. The food court is located in a tall atrium. Upon inspection, you notice that there was a delay in the smoke detection and sprinkler operation because of the stratification. Page 97 to 98 of your handouts. Which of the combustion type is defined as the glowing combustion on the fuel surface and or may not be related in a way to the oxygen content in the vicinity of the process? The answer is A, smoldering. The term blank is defined as the chemical decomposition of a material into one or more other substance because of the heat alone. We call it pyrolysis. Adding up all fuel present and dividing it by the plant area of the compartment or the part space determine what the fuel load, page number 59 of your handouts. A structure in which fuel and air are initially separates and burn in the region in which they mix described with time of flame. Okay, diffusion flame, page 34, which fire class involve combustible materials such as magnesium, titanium, zirconium, etc. That is class D or metal fire, page 115. A structure in which fuel and air are intimately mixed before ignition, described which time of flame, premix flame. That is page 34. Fire can be characterized by all of this except fuel loading, page number 61. Lastly, the process of blank is the action of the hot gas rising due to buoyancy, causing cooling air to flow into the flame from the surrounding atmosphere. We call it entrainment. So we are ready tonight, no? So that's all for tonight. I think there's no questions. So again, congratulations, Mr. Rahil, because you got the perfect answer. And Mr. Castillo also, you're getting a very good score. Keep it up. Mr. Arnel, okay. Also, congratulations. Keep it up. So those but many passed, no? So those who didn't pass, you just, again, I think you need to better, again, read your handout, your module, no, in order to further understand that, okay? So that's all for tonight, guys. Thank you for coming. And again, I'm hoping to see you again next meeting this coming Monday. Am I right? Yeah, Monday. And have a pleasant evening to everyone. Bye bye.